And I give you another example. If this R is CH3, which means it's an alanine, then going through stress degradation, what's going to be the final products taste like? It's nutty. There is lots of the examples. Therefore, stress degradation is important because depends on what type of the amino acids there, you're going to generate different flavor and different taste. Okay? So we almost are done here. There is one thing we haven't talked about. Is we talk about they could be generate some of the carcinogenic mutagen stuff there. Now I'm going to give you an example. So I remove here. Okay, it's a very important example, very easy understanding. But lots of people, they doesn't realize the science behind that. Okay, what I want to talk about is chips. Or French fries, whatever it is. First of all, what are the major components of chips from a nutrition standpoint? Is the glucose. No question about it. You have sugar, that's why it tastes a little bit sweet. You have L, asparagines there. Do you still remember what is the structure of the L of the asparagine? That's why I want to talk about that. What it looks like, CH2, CO, and NH2. That's a big issue there. Okay, chips, how they do? Frying, is that right? What's the temperature of frying? 120 degrees Celsius to about 200 degrees Celsius. And the chips has a large surface, it's like this. The surface is completely extended. Okay, when they cooked it, what's going to happen? This guy, this is the middle center, this guy. Okay, I should not use this color. This guy gonna comes out. Release. Okay, once you release what you have. This is called aldehyde. Okay, what's going to happen? These are the same. And so simple. What is this? Acrylamide. You heard about that. Mutagens. How they say it? Neurotoxin. So they say don't give kids too much chips because the neurotoxin going to generate. They will become a little bit silly if they eat too much when they grow up. Second, this mutagen will have a minimal impact, I won't say it's large, of carcinogen, which means cancer, is that right?
Is that why they say don't like overcook meats, make it real black?
Yes, we're going to talk about that. Okay, now there is something we want to mention. How they solve the problem of the chips, they do it. Some of the store, let's say, there is a chicken fillet, let's say. They always say their potato is using a genetically modified or maybe organic, and then they say it's going to be safe for the kids. Know why? The chips coming from a potato, is that right? A potato. They do blanching. Before they, how they do blanching? 100 degrees Celsius, maybe like 5 minutes to 8 minutes. When they do branching, this acrylamide amount will be decreased at least 60%. This is something you do easily. The second thing is that you have asparagus there, is that right? Okay, what I'm going to do? I'm going to add asparagine oxidase. Okay, then what this guy become? Once I have this oxidase happens, it's no longer the asparagine, it will become a aspartic acids. This is going to be significantly decrease the acrylamide generates. Now, however, I want to tell you, this mutagen will come all the time, even like you said, the meat products. It will come in through baking, through frying, and through roasting. Because those temperatures is between 120 to 200 degrees Celsius. Now, which methods will not generate the acrylamide? Is boiling. Because the boiling temperature somewhere 95 to 100 degrees Celsius, it's not going to generate the acrylamide. Now, what the other way to do? The research has been showing if the temperature more than 200 degrees Celsius, which means you use a very high temperature to cook, this acrylamide will be decomposed at a higher temperature. However, our meat products is just a fit right there. That's one of the reasons people debated for a long time ago said red meat is a carcinogenic material. Although WHO at the end they get rid of that one. That's one of the reasons. Another reason, of course, is the curing products. You have curing meats there. Is a sodium nitrate there? That's another thing. So this is a reason we talk about. There is some of the mutagens could come out from the Maillard reaction. Okay, we talk so many things. What are going to impact to affect Maillard reaction? Okay, so we're going to move a little bit right there. I'm going to write on the top to see what are going to be the impact. Okay. Number one, pH. Yeah, that's good. Thank you. The pH products. The pH of the products. Basically, the lower the pH, the lower the reaction rate. Number two, water activity. So water activity is the best water activity range for Maillard reaction. We mentioned 0.6 to 0.7. That is about 30% relatively humidity, equilibrium relatively humidity. What's the temperature? Usually the temperature increased, the reaction rate will be increased. Now, there is one of the way to prevent Maillard reaction. People say do not use reducing sugar, use modified sugar, which means they take out of the hemiacetal. Or don't let the free available aldehyde to show up, but it's hard to do. There is another way people say you can add sulfur dioxide. What is this? NaHSO3. Why? Because the aldehyde will react with sulfur dioxide and become a components. Just to combine everything together. Okay? However, there is a disadvantage of this process. If the food products, there is a containing thiamine, which is amino acid, thiamine, then you cannot use these methods because this will react with that. So the nutrition value will be significantly decreased. Okay? So That's something we have today. We talk about the Maillard reaction. We talk about the story, we talk about the Hodge, schedule of the reactions. So here, 1-2 analyzation for brownish color, 2-3 analyzation for the flavor, and the aroma, especially structure degradation, contribute for the aroma generate.
The second one there, the water activity, does that increase the rate or decrease?
It's water activity is a range. If you still remember the curve is right there. At the first, if it's very low water activity, we don't mind. That's for the lipids oxidation. At the center middle, we care about it because it's Maillard reaction. Milk powder is in there. Last section, we don't care because it's all meat. And remember, when you cook the meat, the moisture gonna come. So at one moment, at that intermediate stage, the water activity is lower actually. But end product is higher because it retracts some of the water later. Okay? So that's important. Basically, pH is low, the reaction will be lower. Temperature increase, the reaction will be increased, but not higher than 200. If you're higher than 200 degrees Celsius, that's another story because the products will be decomposite. And you can add sulfur dioxide to do a prevention, but make sure the product there's no cyan in there. Okay, so that's all I have today.